Once again, we are back to continue with our lessons. In this lesson today, we'll be talking about electrical load economic dispatch. Electrical load economic dispatch. Then I'd like to break down some of the words that make up the topic. We have the load. There is a word called load in the topic. So when you talk about load, what is a load in electrical engineering? We are talking about load. We said it is a device that takes power from the source, or it is a device that consumes power from the electrical source. So it is a load. It is a device, briefly, that is a load. Then let's also talk about economic. What do we mean by economic in electrical engineering? We are talking about how you can manage the fuel that you are using to generate an electrical power, or how you can manage the power that you generated so that you'll be able to meet your load demand, or you'll be able to meet your monthly demand, or your daily demand, or your whole yearly demand as a country. So economically, we are talking about how you will manage either your fuel that you are using to generate or the generated power, how you are managing it. So we are talking about fuel management or electrical power management. Now let's talk about dispatch. What is a dispatch here? The word dispatch is basically talking about how you distribute your electrical energy that you have generated. After the generation, how much did you give to load 1? How much do you give to load 2? To the other point, dispatch can also be explained in this context to be like you have 2 or more generators. Then you have a load demand. Then it is then as an engineer to see whose generator and other generator should come on board so that its power output will be able to what? To control the load. So we are talking about distribution of power generation among generators. Power generation distribution among generators. So now that we have been able to explain the various words in the topic, now in electrical engineering, you can generate electrical power from so many means and so many ways. But basically, this topic, which is talking about how you'll be able to generate power and how you're able to manage it so that you gain more profit to be able to run the generation station. So we're talking about, you can use water to generate electrical energy, which we call what? The hydro plant. We'll be talking about we can generate power through the solar panel generation. We can talk about the nuclear energy generation power plants. We can also talk about the thermal energy plant. And many others. But when you pick all this and looked at it, rather than hydro, you need water to be able to do your generation. So here you can manage, you don't need a lot of technology to manage the flow rate of water into your turbine. Solar too, it is from the natural sun. You don't need any device or technology to be able to manage the amount of radiations of the solar ray. Then we talk about nuclear and thermal. So today we'll briefly be talking about the nuclear and the thermal energy, the ways of generating our thermal energy. When we're talking about thermal generation power plant, we'll see how do we use economic dispatch technology to be able to manage the amount of fuel that we are using to generate our electrical energy. When we are talking about thermal plant, basically we are talking about burning a liquefied or a fluid fuel into a steam, and that steam is then used to turn the turbine of the generator. And as the turbine have a rotor coupled to the generator, as the turbine is turning, it causes the rotor to rotate among the winding of the generator, and EMF is induced. So that is what basically we are coming to see. How do we apply this technology so that the amount of fuel we are buying to generate the steam to turn our generation plant to produce the power, how do we reduce the cost of fuel in our industries? So thermal plant, basically this is the schematic diagram of a thermal plant. We can have a boiler here, then we have this symbol as the turbine, then we can have the generator here, then we have our bus bar here. So this theory, I'm just using this diagram to explain. So this is another boiler. We have the thermal plant, the turbines here, we have the generator here. So let's say this is the fuel you want to inject. So this is boiler 1. Maybe boiler 2, then generator 1, generator 2. Then the power output of this generator we call P1 and this P2. And all this will come to what? To the load. So it's basically talking about if we want to generate power to meet the load demand out here, then you have 2 or more generators. The output of this generator and the output of you people have the service you are not going. Should we? Alright. So as thermal generation plant is one of the generation plants that you need to buy fuel for you to be able to get the power generated. So we have to apply economic dispatch technology here to see, in case you have a low demand here, now you're having about 3 different generation plants. Then as an electrical engineer, you need to then apply an economic dispatch here. Dispatch, as I explained, means what? Distribution. How do you then distribute the demand among these 3 generation plants? Let's say the output here P1 plus the output of P2 may be able to meet what? Your demand. Then you put the generator 3 or plant 3 at rest. So that economically, if this is the fuel coming in, the amount of fuel inside here and the amount of fuel inside here, when you sum the cost, it will be more lesser than when you sum the 3 fuel costs to what? Together. So that means that you are managing the distribution of what? Your power, at the same time managing the amount of energy you are generating. And as well, you are economically maintaining and balancing your generation plans so that maintenance will not be what? Done at equal time interval. So when you talk about economic dispatch to be applied into this schematic diagram, basically we are talking about this. When you talk about a thermal generation, you inject some amount of fuel into the boiler. This is the boiler. And this boiler will heat up this fluid into a very high temperature. And this temperature will then convert the fluid content into a steam energy, and that energy of steam power will be able to turn the generator rotor, and as the rotor turns within the course of the generator, then EMF is induced, and when EMF is induced, EMF time the current gives us what? The power generated here, and that power will be injected into this very bus bar. So briefly, we are talking about when you are using a thermal generation plant to run a certain country or to power a certain community, then you need to understand this technology that when you get up and you have your low demand of the country, then you need to study into it that, okay, am I going to turn on generator 1, generator 2 at the same time, or I can turn on generator 1 and generator 3 at the same time so that it will meet the demand. Why are we saying so? We are therefore saying that the output of this generator, maybe this output of the generator may be 50 kilowatts, this one will be 30 kilowatts, and this is 15 kilowatts. Now we are talking about a power demand of 45 kilowatts. Economic dispatch, we are then also taking that. That means that you will need to turn on plan 2 and plan 3. Because if plan 2, that is generator same drawn, let's say the load demand here is 45 kilowatts. Now we have 3 generation plants here. Then as an economic dispatch engineer, you should be able to study to see through that. How do I manage my daily fuel I will use to generate the power? Then how do I also reserve some other plants so that I will not exhaust all the plants at the same time? So get to realize that if you will turn on this plant, you need some certain fuel. If you turn on this, you need a fuel. You turn on this, you need a fuel. But our demand is 45. Then as an electrical engineer who study economic dispatch from me, then you get to know that, okay, if I turn on 30 kilowatts and I turn on 15 kilowatts, I'll be able to what? To meet my demand. Then it means that if I turn on all these 3 plants, it means that I'll be generating 20 kilowatts plus 15 kilowatts plus 30, then we are getting like 65 kilowatts. But we only need 45 kilowatts. And as we all know that engineering, it is very difficult to store electrical energy. It means 20 kilowatts power have been what? Wasted. And as well, it affects what? Fuel have been what? Wasted. And as well as you have wasted the lifespan of what? The machine. You have worked for vain. So that is the advantages of what? Some of the economic dispatch. As an engineer into that production industry, you're able to what? To apply this technology. So, as an electrical engineer who want to manage electrical energy and generation very well, it means that the suitable technology to apply here is that to turn on plan 2 and plan what? 3. So that, since we say generation, power generation must always equal to what? Power demand. So it means this theory have what? Meet it goal. So we say that, okay, turn on, this one is on, this one is on. So it means we have 30 kilowatts plus 15 kilowatts as our generation at the output equals to what? 45 kilowatts. And our demand have been what? Met. So in this, generator or plan 1 is resting. When demand goes down, then you can shut down either generation 2, then generation 1 can come in to meet the demand. Because in electrical engineering, we have what we call peak period and what? Load period. So when the peak period exceeds like there's another load coming in or increase of demand. Now we have 15 kilowatt demand coming in. Now demand is rising to what? 60 kilowatts. Then you can turn on what? Generation 2. The excess of 5 kilowatts can be economically what? Considered as a loss bet. You can go by it. So please today, this is the introduction to economic dispatch. I'll beg that we try to subscribe to this channel and you learn a lot. So the next episode we're talking about the mathematical analysis of how you'll be able to manage the amount of fuel that you need to inject into this plant, the amount of fuel you need to inject to this plant, so that the power demand here will be exact, the output here will be exact. Then when you sum up all in the bus bar, you get your demand. Thank you for subscribing, and thank you for learning from Professor Yuri. Thank you. I thank you for always watching my videos, and I'd like you to drop down any comments you have or any other question you have that you don't understand from your very university you are watching me. You can type it into the comments box. I'll be able to solve it. Thank you for watching ZM channel, and thank you for subscribing. God bless you, and your comments are welcome mostly. Thank you.